Hi, I'm Dan Szafir, and I'm an HRI researcher.
And I'm Danielle Szafir, and I'm a visualization researcher.
And we're here to talk to you today about how to bridge these two fields to drive synergistic innovation for data-centric robotics. To start off, I think it's a really exciting time to be a roboticist, as we're seeing robots being used in increasingly challenging and complex environments and tasks. For example, we just had Perseverance land on Mars, and we're seeing robots used in different types of inspection and mapping and emergency response activities. Now, Danielle, as a viz person, what do you see that's interesting here?
Well, as a viz person, my priority is the data, so let's take a look at what sorts of interfaces are supporting data exchange. Looking at robot interfaces, there's a lot to be excited about from a viz perspective. While the focus of these interfaces is largely on robot operation and supervision, I see lots of interesting data coming together, such as streaming images and video, sensor readings, and information about the environment. There's a lot of potential for using this robot-collected data to accomplish broader goals, such as conducting structural assessments or collecting geospatial data for environmental science.
So that's a really interesting point, and it's the fundamental idea that sparked this project. Traditionally, robot interface design has focused primarily on this question of how do we design interfaces for robot operation and supervision. While this is a critical question, emphasizing only this aspect may obfuscate an increasingly important and highly related question. How can we design robot interfaces that effectively support people in interacting with all the data that robots collect? In other words, how can we craft interfaces for data acquisition, analysis, and decision-making?
Well, the good news is that this question is exactly the core of viz research. This is where we see very clear synergies between the fields of HRI and viz, where one of the main reasons that people build and deploy robots is to collect data, and the primary focus of information visualization is supporting users in analyzing and interacting with data. Let me illustrate this with a quick example. Here I've got 4 data sets, and I've computed first-order statistics for each. Would you say these are fairly similar?
Yep, they look pretty much identical to me.
Well, if we look at the data, we can actually see that they're quite different. Reducing our data to a statistical summary is tempting for its brevity, but people are good pattern detectors. Visualizing these data sets, we can immediately see that we have some data sets that are linear, others that are parabolic. Viz, done well, gives us a rapid understanding of what's going on in our data. We can use our abilities to detect visual patterns to engage in data analysis, the process of exploring and reasoning with data. People can then use their ability to infer patterns coupled with other information like knowledge of context or scientific expertise to engage in sense-making, that is, generating conclusions and actions through data. The desired outcomes of this are what we call insight or concrete and meaningful knowledge, and decision-making or selecting the appropriate course of action given the data. We can use this process to drive better interfaces for working with data. And viz has spent a lot of time developing solutions for working with data and applications that are highly relevant to robotics, such as tools for explainable AI and machine learning, high-dimensional data describing where agents move in a region, and ensembles of uncertain trajectories. But for whatever reason, viz hasn't spent much time thinking about robot interfaces. In fact, only one system for robot data has ever appeared in our top venues, an interface for debugging multi-robot systems which just appeared at Viz 2020.
So where do we go from here? If we do want to start thinking about robot interface design from a viz perspective, are there principles and techniques we can draw on to improve our systems?
Well, for any truly effective system, we need to do a full task-driven design process, and we'll talk about that in a second. But at a high level, there are some useful guidelines for viz that could help generally improve robot interface design. Not that prior interfaces are necessarily ineffective, but when we surveyed the literature on robot interfaces, we did notice some common ways that such interfaces might be improved.
A few of the areas for improvement that we saw across many robot interfaces are poor color choices, too much detail, and too many visualizations. For instance, we often saw rainbow color maps being used, which can cause people to build false associations between unrelated data. And experiments from viz have shown that rainbow maps can decrease user abilities to find critical data by 30% or more.
We also saw lots of interfaces suffer from visual clutter. There's just too much data and too much detail to make sense of it. In viz, there's a general principle of overview first, details on demand that could help people better get the big picture about their data and quickly drill down into the data that matters. We also saw interfaces using too many visualizations, making it hard to know where users should look. Viz offers guidelines for how to design vizes that can support multiple tasks at once. If you're new to this area and looking for a quick crash course in common design pitfalls and solutions, you can check out my article in Interactions magazine for a gentle introduction.
So those are some helpful guidelines from Viz for improving robot interface design generally. But can we get more specific guidance? As a robot interface designer, what exactly is the best way for me to visualize the data in my interface?
Well, unfortunately, it's not that simple. Choosing the right visualization to represent your data depends on the data you have and what you want to know about it. We can start by figuring out what data tasks you need to complete. In other words, what specific questions do you need to answer? We can use these questions to engage in a task-driven design approach to figure out what visualization design will let you build the knowledge you need to achieve your goals. In HRI, we also need to consider your robotics tasks, including operation and supervision.
To this end, we've developed a Datacentric HRI Framework to help robot interface designers better reason about how they're representing data and link to best practices in visualization. Our framework is based on the notion that humans and robots work together to achieve shared team objectives, and focuses on the flow of information across the team. In our model, each individual team member carries out various activities, formed through sequences of actions, in service to the objective. For example, activities might consist of things like exploring an environment or inspecting a structure, with human actions being things like tasking the robot to collect data at a particular location or annotating a resulting data set, with robot actions being things such as navigating to a particular location or querying a human to see if it is safe for the robot to proceed. Now, how to support effective communication that links human and robot actions has long been a focus of HRI research. However, both human and robot actions themselves don't exist in a vacuum, but are informed by other processes. For example, robot actions are supported by various autonomous capabilities of the platform itself, and here we can think about this from the traditional sense plan act paradigm, where information from a robot perception system can inform its reasoning and planning. How these robotic subsystems interact has often been the focus of traditional robotics. On the human side of things, human actions are informed by people's understanding of the data, where humans perform various low-level data tasks, such as examining a camera feed or scanning a log file. These data tasks, informed by raw and processed data that flows from robots to users, drive higher-level knowledge formation, where humans integrate various patterns and statistics to form various insights that drive human actions and activities. This data analysis process is the traditional focus of Viz.
At a high level, this framework aims to bridge perspectives across HRI, robotics, and Viz to inform systems that enable humans and robots to collaboratively achieve a given objective. One of the key pieces of this framework is the importance of the data analysis process in human-robot teaming, particularly this role of data tasks. We surveyed field robotics literature and identified 7 common data tasks people need to address through robot interfaces. They need to find relevant information, directing their attention towards data that matters, synthesize data across sources such as multiple sensors or agents, develop and maintain awareness both at the local and global level, monitor data quality by assessing data coverage and validity, identify anomalies by finding unusual or unexpected patterns arising in data, make predictions using that data to estimate the future states of the objective, and to assess risks by estimating the costs of different courses of action. These tasks give an easy bridge into relevant concepts and visualization that could inform interface design. We don't have time to get into specific details here, but you can check out the paper for a range of pointers.
So the data tasks are a key area where HRI can draw insight from Viz in terms of how the data analysis pipeline may affect human actions and activities. In improving human-robot interfaces, one additional element of our framework is that we highlight how different activities can involve different types of data tasks. Our framework synthesizes 4 archetypal activities for HRI: environment navigation and exploration, manipulation, inspection and search, and debugging and error recovery. For example, the activity of environment navigation, getting a robot from a starting location to a known target location, will heavily involve the data task of synthesizing data across sources, such as combining info from various camera feeds and maps, while the activity of debugging and error recovery may focus more on data tasks involving finding relevant information and identifying anomalies. Please see our paper for more details, where we discuss each data task in the context of these activities.
To recap, our overall goal is to provide robot interface designers with a framework for data-centric HRI, to better consider how users will analyze and interact with robot-collected data, and to identify key areas where they may draw on related research from the DataViz community.
To make this more actionable, we have also developed a tool in the form of a work table that robot interface designers can fill in to identify each of these components and break down the data analysis process into relevant data tasks and identify relevant practices from Viz. In our paper appendix, we provide an example of how to use this tool, where we take an existing robot interface and show an example redesign that leverages modern visualization techniques. Please see our paper for more details and our project website to download this tool.
Ultimately, our goal here is to better link HRI and Viz, which we believe have a number of natural synergies. While we focus primarily on robot interface design here, there are several other opportunities at the cutting edge of these fields, such as exploring AR/VR interfaces and explainable AI for human-AI teaming. In short, we still have lots of work to do.
We're excited to explore some of these ideas with you in the future and hope you'll join us in bridging HRI and Viz. Thank you so much for watching, and please don't hesitate to reach out to us with questions.